Yeah, once again, good morning, one and all, one and all. We are discussing hashing mechanism. You know, why hashing is required and what is the purpose we are really implementing hashing, you know very well. In that process, we learn hashing is going to search the element with the constant time. So this is the main idea behind of this hashing mechanism. If we want to understand hashing, you are going to develop the first of all hash function as well as hash table. Here always we are going to insert element with help of hash function because hash function always generates the hash value from the input data. That input data we are going to store in the hash table with help of the hash value. Yeah, that is why always the insertion, deletion, search, everything is depending on that particular hash function. Yeah, that is why the hash function is very important. If your hash function is good and your hash function is having good efficiency, the hashing technique is providing the constant time complexity. That is big O of one. If your hash function is poor, here how we can tell the hash function is poor? Here when we are inserting a element, here we are getting same hash value for multiple input data. Here there is a chance of a collision. Here such problem is called as collision. Here if you are not solving collision with help of linear probing, then that is called as overflow. Here for that we are discussing further collision resolution solutions. Here, I think we are completed 3 to 4 mechanism to overcome these collision problems. Here, can you tell anyone what are the things we discussed in the last class regarding to collision handling? Anyone, please? What are the techniques we discussed in the last class? My question is, we are actually discussing collision overcoming techniques, collision resolving techniques. Some of the techniques we discussed, I think 3 to 4. Can you please tell the names of that? No answer.
Linear probing,
Yeah, linear probing.
problem with linear probing,
Yeah, linear probing is the technique. The disadvantage is the problem. Okay, that is okay. Only linear probing. Okay.
double
Next,
hash,
double hashing. Okay, good. One more technique. First technique you are Mr. Manasa. What is the first technique we discussed?
overflow,
No, Manasa, I am asking techniques. No one.
Separate chaining.
Yeah, separate chaining is the first technique. Next one is the linear probing. Next one, next one.
quadratic probing.
Huh? Rahul, tell me.
The quadratic probing.
Quadratic probing. Because of the linear probing, there is a problem. Overflow problem will occur. Here, to overcome the particular problem, we discussed about quadratic probing. Here, after quadratic probing, what we discussed? Double hashing. Correct? Double hashing is done.
yes sir.
Yeah. Now, today we are going to learn 2 more techniques, that is rehashing and extensible hashing. Is the screen is visible now? Is the screen is visible?
Yes, sir.
Yeah. If you are going to observe hashing mechanism, you know hash table, hash functions, the block diagram of hash table and hash function, and hash functions, types of basic hash functions. You know the division method, mid-square method, multiplicative hash function, and digit folding. Here, because of these methods, there is a chance of collision. You know what is the collision? The hash function is going to return uh, same hash value for multiple input data. Such problem is called as collision. To overcome this collision, we have some separate mechanisms. That is separate chaining. We are discussing the last class, and open addressing. It is also called as linear probing. When you are using this linear probing, there is a chance of the problem. Here, this is nothing but a clustering. To avoid this clustering, they implemented quadratic probing. Means you have to add I value, I square value for every hash key value before division of that particular input. That is what exactly the quadratic probing. Here, one more method also we discussed in the last class, that is double hashing. The double hashing is a mechanism. It contains two hash functions. Here we have to use the function like division method. If any collision is occurred with this first hash function, that is any collision is occurred that particular first hash function, which is division method. Once the collision is occurred, then we are going to use the second hash function. Always the second hash function provides the after collision how many locations we have to insert that particular input value. Here it is going to do like that. So that's why here the second hash function contains m minus key mod of m. M is a the prime number which is less than the table size. And also we discussed about this, and also we discussed one more point also. What is that? Always we have to consider the highest prime value of that particular table size. Yeah, that is what we discussed in the last class. Correct? Done? Up to this?
Yes, sir.
Yeah. Now today we are going to learn about the rehashing. A rehashing is a mechanism, very simple mechanism. Once the collision is done, we are doing some hash function. We have to use the hash function. If the division method I am using here also. But when we are doing this hashing implementation, here once the collision is occurred, again we have to rehash it. Here at the time of rehashing, what are the things we have to do that? So just we have to understand that before implementation of that rehashing, we have to remember these following three important points. That is the first one is here when table is completely full, rehashing required. These are the situation. When the situation is these three situations, we can apply this rehashing mechanism. That is when table is completely full. Yes, if we are using the division method, the table is full. If the table is full, there is no chance to insert the element. That's why you have to apply a rehashing mechanism. Then how to apply, I will tell you. First of all, when you have to apply, we are going to remember. Then if we are using quadratic probing, so this is for linear probing. Okay, when we are using quadratic probing, here the table is filled with half. Only half of the table is filled. Then you must go with the again the rehashing. Means if you are using quadratic, means the quadratic never follows the clustering mechanism, but this uh, linear probing follows clustering mechanism. There is a chance of full of the table. But here coming to the quadratic probing, there is no chance of the full of the table. Only the thing is if the table is filled, only half of the table is filled. In such case, we have to use the rehashing mechanism. Now, third one is when insertion fail due to overflow. The overflow means you know already when the collision is occurred, we are going to set the next to following room. The next to following room is free, then you can insert. Even though the next room is not free until end of the table also, the such problem is called as overflow. Means when you are inserting element, okay, here it is going to fail because of the overflow. Then you can apply rehashing mechanism. Now clear this? Here, these are the three situations we are going to apply rehashing mechanism. Clear this? What is the rehashing? I will tell you. All of you clear this. When should we apply rehashing? Hello? Hello? Are you there?
Yes, sir.
Yeah. Please respond, then only I can continue because I cannot, I don't know really you are following or not. That's what. Here, what are the real thing of reaction? Exactly what we have to do. Here, here the table is resized. When we are going to apply rehashing, here the table is going to resize. Means the table is going to change. For example, your table is 10. Here we have to double that particular table. The table, for example, you know how to apply uh, division method. For example, h of k equal to k module the table size. The table size is 10 if I consider. Here once the
Hello,
yeah, yeah, tell me.
sir. My friend is waiting. Accept the answer.
Here it is, there is no accepting mechanism. It is going to accept automatically because I have
He is
not.
waiting, sir.
No, Prakash. Here I install one app. That app is going to accept everyone. I don't need to accept anyone. I'm not accepting anyone. Directly it is going to join. Are you clear?
Okay, sir.
Sure. Please, that is what yesterday also one guy has told me like that. That is the reason I don't want to accept everyone. Directly one patch I install in the Google Meet. Automatically it is going to accept without any acceptance from the user. Please. Well, you tell him, okay? Once again, you tell him you join proper way. Then only proper way means maybe internet connectivity, maybe right link, maybe right device, maybe. Okay? Are you clear, Prakash? Again, is okay. Now, please, everyone respond here. Add function. Okay. Here, this is my add function I am using the division method. Once the collision is occurred because of these three situations, means when I am using linear probing, the table is full. When I am using quadratic probing, the table is half filled. When I am trying to insert element, but overflow is occurred, I am not inserting that particular element. Here, these three situations we are going to apply rehashing mechanism. The rehashing mechanism is nothing but we are going to double the size of the table. To double the size of the table means what is the actually the table size is what earlier before collision occurred, what is the table size? Have taken here
10.
10. Now double the size means what is your answer? What is the divisor now?
20.
20. But here this is the 20 directly. But when you are doubling, here that particular after doubling that particular size must be a prime number. You must use near prime number. Now tell me what should I take after doubling of my table? Then how much I can use the table size now? K module. What is the value I have to consider now? K module 20, but 20 is not a right value. I told you just now. You have to take prime number, nearer prime number. Can anyone tell what is the nearer prime number for 20? Hello? Hello? Are you there?
19, sir.
Yeah, 19 is the prime number nearer, but always you consider double, right? Double means 20. Minimum is 20, right? Compulsory. Means you go with the upper,
Yes,
don't come to the lower. That's why what is the nearer prime number? Means upper. Compulsory it must be double, right? If 19, if you take it is not double. It is minimum double and it is a prime number. Now what is the prime
23.
number? 20?
3.
3. Yes, we have to consider 23. Now the table size is 23. You have to double the table size. Here, then that must be the prime number. That's why here we consider the prime number which is nearer to 20, that is a 23. So now we have to use this particular hash function for rehashing. Are you clear? Now again we have to hash, again we have to insert all the values using this particular hash function. Even though after inserting again some of the situation, if you get any collision, then what should we do? Again we have to double it. Here what is that? 46. Here 46 nearer prime number. What is the 46 nearer prime number? Can anyone tell? What is the nearer prime number for 46? Hello?
47.
47. We must use 47. Understood now? Here, when the collision is occurred, you double the size of the table and you take the nearer prime number, means upper level only, not lower, upper nearer one. Here, and use the table size and use the same hash function, then there is no chance of the collision. That is the rehashing. Understand the mechanism? You understood? Understood? Hello?
Yes, sir.
Yeah. Now I will show you one example, very simple example, then you can understand. Here, now you know this is a division method, right? Yes or no? What is that? H of k equal to k modulus. Here, what is the size of the table now? Tell me anyone?
10.
10. Then I am using 10. Yes, then for 37, what is the hash value?
7.
7. Now we are going to insert it 7. Okay, inserted. Now for 90, what is the hash value? For 90, what is the hash value?
0.
0. I inserted in the hash table at 0 position. 55 hash value?
5.
5. Very good. I inserted at 55. Now 22 hash value?
2.
2. Now I inserted it 2 indexing of hash table. 17 hash value?
7.
7. Means here the collision is occurred. Are you clear? Are you
Yes.
clear? Here, once the collision is occurred, what should we do?
Double.
Double the size of the table. Here, 20. Here again, that must be the prime number. Then what should we take?
23.
Here, k modulus 23. Understand? Understand?
Yes, sir.
Here, once the collision is occurred here. Then use this hash function. Again, you have to insert all these values using this. 0 to 22, we have to prepare hash table. Then 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 16, 17, 18, 19, 20, 21. Now this is the hash table. Now resize the hash table. Now tell me again we have to insert it. Now tell me what is the 37 hash value now? 37. Now what happened? 37 modulus 23. Then tell me what is the hash value? So 37 module 23. Then what is the hash value? It will generate. Hello? Hello? Are you there? Huh? Are you there? How to know the modulus value? 23,
14.
37. Now one time 23. Uh, then what will come? Here 4 and 1. This is the remainder. Now 14. Now we have to insert 37 at 14th. Clear? Clear. Then what is the 90 hash value? Tell me. 90 module 23. Then tell me how many times? Here you are all are from mathematics. Please do it fast. What is the hash value for 90? Hello. You people are poor in mathematics. Hello. Don't waste your time, please. Huh? Sorry. What is the remainder?
21.
21. Okay, 21. She is telling 21. I don't know. 21. Now 90 is going to insert it 21. Right. Now next 55. 55. Here all of you must work with your notebook. Then only it will be done. Simply your listening means waste. You cannot understand. Now tell me. 55 modulus 23.
9.
9. Now this 55 is going to insert at 9th index. Next one, 22. 22. Tell me. 22 modulus 23. What will come? Hello? 22 modulus 23. What will come? What is the remainder? Simple. You all are, I think you
22, sir.
0.
22 only. Very good. 22 only. You know, it is lesser than that, right? 22 only. Very good. Please respond. Now 17. 17 only. Yeah, this simple mathematics you are not solving means 49. Tell me 49. 49. How many times?
3.
How many times? 2 times. Correct. Then remainder is 3. Now 49 is inserted at 3 index. Now 87. How many times? I think 3 times. Then remainder.
8.
What is the remainder? Huh?
18.
18, sir.
18. 87 inserted at 18. Now still there is no collision, right? Yes or no?
Yes, sir.
Here,
Yes,
once
sir.
now again you insert more elements like this if you require. Here, what is the collision is occurred? What should we do? Again, we have to double the size of the table. So the table size must be near prime number you have to consider. Then we have to use the hash function, and again you have to insert all the elements in that particular hash table. Now, understood everyone? Understood everyone? This is the rehashing.
Yes, sir.
Yeah. Shall I go with next topic? Shall I go with next topic?
Yes,
Hello.
sir.
Yeah. Please respond as early as possible. Now, the last topic is extensible hashing. So this extensible hashing is whatever the hashing mechanisms we discussed previously, five techniques, all are we use division method for to solve the collision problem. But coming to the extensible hashing, this extensible hashing is completely different mechanism. Here it is completely depending on the binary system. I think everyone knows binary system, right? Everyone knows binary system, yes or no?
Yes, sir.
Yeah. Here, if you know the binary mechanism, then this extensible hashing you can understand very easily. Here, for this extensible hashing, we have to use for large data. Large data. If you wanted to manage your large data, then we have to use the extensible hashing. So that extensible hashing which handles a large amount of data. Yes, if you are having large data to store in a hash table, then you must choose the extensible hashing. That is why. Okay. Now, when you are using this extensible hashing, it is the table is going to grows and shrinks similar to beatrice. Beatrice is you are going to learn this beatrice end of the chapter. Here, beatrice also it is going to shrink and grow. Means number of elements are increasing, the table is going to grow. The number of elements are going to decreasing, the table is going to shrink. And that is why here, that is why this particular hashing table is going to shrink and grow as per the input data. Are you clear? Sir, I will show you that meaning also. Don't worry. Now, it referring the size of direct dictionary, the elements are to be placed in buckets. The levels are indicated in the panel. I will tell you. Don't worry. Now, coming to this, here always in this extensible hashing, here buckets are there. Here always bucket is nothing but a memory. So don't feel bucket is means something is discussed. No, bucket is nothing but a memory block. Are you clear? Are you clear? Bucket is nothing but a memory block.
Yes, sir.
Yeah. Now, here initially, you know, what are the binary numbers? What are the initial binary numbers? Anyone tell? What are the initial binary numbers? Hello?
0 seconds.
0 or 1. You know, the binary initial numbers. Then, first of all, we have to consider the binary number is 0. Then we have to go with 1, correct? Yes or no? Off and
Yes.
on. Yeah, so that is why initially when we are going to observe the bucket indexing value is 0. The first bucket indexing value is 0. Now I am going to take the global size of the bucket 2. Always you can take any size. If I take 2, the global size, then this bucket is going to accept only two values. So this bucket is going to accept only two values. Here again, I want to insert this triple one. I want to insert this triple one. Is it possible now? Because it is going to accept only how many values? Two only. Always my bucket is going to accept because I said I given the global size of bucket is two. If you want to give three, then bucket is going to accept three values. If you want to given only one, it is going to accept only one value. If you are given 10, it is going to accept 10 value. But here I have taken two. Why I have taken two, I will tell you later. First of all, you can use any size of the bucket, but here I am using only the size is two. Then it is going to accept two values. Are you clear? That's why it is accepted only two values. When I want to insert this value, this bucket is going to accept, the zero bucket is going to accept, the zero bucket is going to accept or not?
Sir,
Hello?
can you repeat once again?
Here, bucket is nothing but a memory block. Here we are representing the bucket with help of the binary format numbers. Okay. Here initially we know the zero bucket. Later we go with one bucket. Later what we will go, I will tell you. Here initially we have two binary numbers, 0 and 1. This is the combination. Correct? You are asking, but you are not
Yes,
replying.
sir.
Is it right?
Yes, sir.
Yeah, reply that asking and replying is very important because we are not each other, please. Now, your zero bucket, that's why I have considered zero bucket, but global size of the bucket I have taken two. So every bucket is going to occupy, it is going to accept only two elements, means the bucket size I prepared globally two. Sir, why should we prepare two? No, you can use any size of the bucket. You can use 5, 6, 7, 10, whatever the size you can set as a global value, you can set it. But initially, I was taken two. Why I have taken two, I will tell you later. If you want to take 10, 20, 30, 50, also not a problem. Clear now? Size is nothing
Yes, sir.
but it is going to accept that many elements only. Clear? Bucket is nothing but a memory. Here, the technical we called bucket. The meaning is memory block. Clear?
Yes, sir.
Yeah. Now, initially the zero bucket I have taken. Now I inserted two values. That's why the size I mentioned here, two. Two means this bucket contains two. Now it is reached to the global size. What is the global size? I have fixed to two. That's why here again I am trying to insert triple one. Now this bucket, zero bucket is going to accept this value.
No, sir.
No. Here, when the bucket is not accepting, then you are going to extend your bucket. Now, here one bucket is created. It is extended. So this is one bucket. Now this one bucket is added this value, triple one. Now this bucket size is one. Correct? The level is one. Correct.
Yes, sir.
Yes, sir.
Yes,
Here
sir.
it means if we want to insert one more element in this bucket, yes, it is possible. Possible or not? Because the global size is not reached. Understand? Understand? Hello? Hello?
Yes, sir.
Yeah, this is level and this is the directory. Means always the bucket is going to represent with one number. Yeah, that is nothing but a directory. It is going to access the data of the bucket very quickly. That's why it is looking like a directory. Yeah, this is the basic structure of the extensible hashing. I will show you the example. You can understand more clearly. Yeah, this is the only the basic structure. You understood basic structure. What is a dictionary and what is the level and what is the bucket? Clear now? And what is the global size? Clear now?
Yes, sir.
Now coming to the example. Now here in this example also I have taken the global depth. The global depth I have taken two only in this example. So please consider why I have taken two. I will tell you later. And after this example, I will tell you why I have taken two, why I have not taken 10, 20. Okay, I will tell you later. First of all, the zero bucket we have to create when the element you want to insert. The first element is 1, I want to insert. Sir, what is the first element binary value? Tell me what is the one binary value? What is the binary value of 1? Hello.
0,
Sorry?
001.
Yeah, 001. That's why I inserted first element in the zero bucket because there is no competition. That's why you have to take the first element. We have to insert it first bucket only. Yes or no? There is no two, three buckets. Only one bucket we have. So that's why directly without any verification, without any search, we are going to insert at 0th bucket. So that is 001 is inserted. That time the level is 1. Okay, the level is 1. Now next element 4. What is the binary value of 4? What is the binary value of 4?
100.
100. Here again we have only one bucket, then again we are inserted. The level is 2. Now 100 is inserted in the 0 bucket. Fine now? Initially. This is initial mechanism. Fine? Hello?
Yes, sir.
Now I want to insert 5. Now tell me what is the 5 binary value? What is the 5 binary value? Hello? What is the value of
101.
1, 0, 1? Now I am trying to insert 0 bucket, but it is not inserting. Why? Why? Why it is not inserting?
Because because the global value is P.
Now I have taken the bucket size is 2 only, the global depth is 2 only. That's why it is not possible to insert in this bucket. So that's why we have to extend your bucket. We have to extend your bucket. That's why it is extensible hashing. So that's why you are going to extend your bucket. Here, what is the bucket we have generated? 0. Then what is the next bucket? Here, 0. After 0, 1 bucket is there. Are you clear? Are you clear? Hello? 0 already is there. Now, next bucket we have to create as a 1. Are you clear? Hello? No response, I cannot continue. Time is very less. At least we have to finish this unit today. Here, 0 bucket already we are created. This is not possible to insert. Again, we need one more bucket. Here, after 0, we have only option 1. That's why I have created one bucket. Are you clear?
Yes, sir.
Yes, sir.
Yeah, please respond quickly. Right. Here now, here how many values are there here to insert these buckets? 001, 100, 101. Now we have 2 buckets. So then we have to apply hashing here. If only one bucket, there is no chance to apply hash because only one. You people are having only one room. Then everything you have to keep all your books, material, and your kitchen, everything you have to set up in this only one room. Yes or no? Yes or no?
Yes, sir.
In your house, 2 rooms are there. Then we are going to arrange your data as per your requirement. Yes or no? We are going to distribute your data. Means your kitchen is one room and books is another room. Like that, we have to plan. Yes or no?
Yes, sir.
In that way, same way, now we have to use hashing for searching of element very quickly. Here now, here in this case, 001, 100, 101. These 3 values you have to insert it. Yes or no? You have to distribute it. Now, in this be 0, here which data is having the last element is 1, if that data you have to insert into the 1 bucket. Now tell me 001 is going to insert into where? We have to insert 00 into which bucket? 0 bucket or 1 bucket? Hello? Hello?
One bucket.
1 bucket because the last digit is 1. That's why here we are inserted 001 at 1 bucket. For searching also very fast, right? When anyone is going to search 001 means they will think, oh, last digit is 1. Then he will move to the 1 bucket. You understand now? Now hashing is implemented here. Understood now?
Yes, sir.
Yeah. Now 100. Here 100. Last digit is 0. Where should we have to insert here?
0 buck.
0 bucket because last element is 0. Here searching is fast. That means we are applying hashing mechanism. So now 101. Where should we have to insert 101?
1 bucket.
1 bucket. Very good. Right. The next element is 7. Sir, what is the binary value of 7? Tell me. What is the binary value of 7?
One.
Triple 1.
111.
Sir, last element is 1. Where should we insert?
1 bucket.
1 bucket. Sir, when we are inserting 1 bucket, what is the problem? What is the problem? Directly we can
Global
insert. Is
depth
there
is
any problem? Global depth is reached means for every bucket we are fixed only the size of the bucket is 2 elements only. But here the one bucket already reached to global depth. Yes or no?
Yes, sir.
Yes,
So
sir.
that's why we have to extend your buckets. That means we have to implement extensible of your bucket. That is 0, 0 bucket, 0, 1 bucket, 1, 0 bucket, 1, 1 bucket. Correct? Understand? This is zero generally normal our numbering system 0, 1, 2, 3. Your binary numbering system 0, 0 bucket, 0, 1 bucket, 1, 0 bucket, 1, 1 bucket. Understand?
Yes, sir.
Now here two digits are there. Means we have to apply hashing mechanism for last 2 digits. Now tell me, here what are the numbers? 1, 2, 3, 4 numbers are there. Now tell me 1, 0, 0 is going to insert into where?
0 bucket.
Yeah, 0, 0 bucket because last 2 digits are 0. Yes, we have inserted it. 0, 0 bucket. Now 0, 0, 1 element. Where it is going to insert?
0 1 bucket.
0, 1 bucket because last 2 digits are 0, 1. Here 1, 0, 1. Where it is going to insert?
0 1 bucket.
0, 1 bucket. Yes, now it is reached to the global depth. Now we cannot insert any element. If you want to insert again, you have to extend your hash table, please. Now next one is what? Triple one. Where it is going to insert?
Double 1 bucket.
Double 1 bucket. Now this is the after insertion of 7. Here this is your extension hashing table. Understand? Now
Yes,
1, 0 is not having any element. That's why the level is 0 here. Here the level is 1. Here the level is 1. Understand?
yes, sir.
Now I want to insert 8 now. So what is the hash value of 8? Tell me. What is the hash value of 8? 8
1
hash value. 1,
000.
0, 0. So where we are going to insert this 1, 0,
0 0.
0, 0 bucket? Is there any problem?
No, sir.
No problem. That's why we are inserted here. Now global depth is reached to 2. Understand?
Yes, sir.
Here, now I want to insert 10. What is the hash value of 10?
1 0 1 0.
1, 0, 1, 0. Where we are going to insert this 1, 0, 1, 0?
In 1
1
0.
0.
1, 0 bucket. Is there any problem?
No, sir.
No problem. Then the level is 1 now. 1, 0, 1, 0. Understand? Like that, we can insert more numbers. Understand this?
Yes, sir.
Once again, this problem will come. Means it is out of the global depth. Then again, your buckets are going to extend. What are the buckets will come? 0, 0, 0 bucket. 0. Tell me. 0, 0, 1 bucket means we will get 8 buckets, right? 0, 0, 0 bucket. 0, 0, 1 bucket. 0, 1, 0 bucket and
1
0, 1, 1 bucket. 1, 0, 0 bucket. Are you following? 1, 0, 1 bucket. We have to add 1, 1. 1, 1, 0 bucket and 1, 1, 1. Correct?
Yes, sir.
Now here, now we get 8 buckets. Now again, you have to rearrange your data, shuffle your data as per the last 2 digits. Are you clear?
Yes, sir.
Again, you will get any problem. Means out of the globe, this global depth. Again, your buckets are going to shuffle. How? 4 digits will come.
16.
16 will come. 16 buckets will generate. Yes or no? 0, 0, 0. Next one is 0, 0, 0, 1. Then 0, 0, 1, 0. Then 0, 0, 1, 1. Then 0, 1, 0, 0. Correct? What I am telling, understood everyone?
Yes, sir.
So this is the way we are going to extend your buckets for this extensible action. Understood everyone? Understand this?
Yes, sir.
Yeah, please, this is very, very important. Compulsory, you can expect a question from here. And one more thing, why I have taken the global depth is 2. Sir, if you are going to observe, why can't we take global depth is 10? Or global depth is, if you take global depth is 10, what happened? Tell me. If I take global depth is 10, what happened? In zero bucket only, we can insert how many elements? How many elements we can insert?
10
10
elements.
elements. Now, when you want to search one particular element in this zero bucket, then how many comparisons are required?
10 comparison.
10 comparisons. So, like that, we have so many buckets. So, like that, we need these comparisons are increasing. If you are using depth is 100, then 100 comparisons are required. So, this is the problem. So, when we are using this hashing, then again the searchings are required more searchings, then the time complexity is increasing. So that is why if you take the minimum global depth, the searching is very easy. If you are going to move to the zero bucket, if this global depth is 2, how many comparisons are required to search element after entering of that bucket? The global depth is 2, the maximum how many comparisons required after entering into that bucket?
2.
2, maximum 2 means that the global depth is nothing but the time complexity of that particular extensible hashing mechanism. Yes or no?
Yes, sir.
Yeah, means the global depth is increasing, then your time complexity is increasing or not.
Yes, sir.
Here, that's why here the global depth always you have to take very less number. Yes or no? Even you can take 3 also not a problem. These 3 comparisons are required. If you go with beyond this, what happened? Your time complexity is going to increase for searching of element. Is it right or wrong?
Yes, sir.
So that is why I have taken the global depth is 2 here. Even though you can take up to 5, not a problem. 3, 4, 5 also not a problem. Because 5 is not an issue. Are you clear? Because anyway, the based on the last digits, we can find the which bucket we are belongs. That 0, 0 is the last element. Like that, we have to move. Here, only one, within one comparison, we are going to identify the particular bucket, which bucket we have to move. Here, after entering that bucket, we know the based on the global depth only we are going to search. So that's why the global depth is going to play a vital role when we are going to use this extensible hashing. Is it fine now? You are clear now? Why I have taken the global depth is less number?
Yes, sir.
Everyone is clear this hashing mechanisms. Now second unit is closed. If you are clear, then second unit is already closed now. That is what I am asking. Is it clear, everyone? Hello?
Yes, sir.
Hello? Yeah.
Hello, sir.
Yeah, tell me.
Sir, as in the case we saw, a bucket has a limit of 2 values, sir.
Okay. Sorry. The global depth is meaning is that is on the bucket is going to accept maximum 2 elements.
So, what if there are 3 elements with the same ending values?
Sorry,
What
I'm
if
not
there
on.
are three values with the same ending, sir? Same binary values that are ending with
That is why
like.
you have to extend the table. Once you will get any collision, then you move to the you extend your bucket. Okay, that is what I told you, right?
Okay, yes, sir. Okay, sir.
Here, once the bucket is full, means how can you tell the bucket is full? Here it is reaches to the global depth. You have taken the global depth is 3, for example. So that bucket is going to accept only 3 input data. Here, after a fourth element we are trying to insert in that bucket only, then your buckets are going to extendable. You have to extend it. Means your buckets are going to increase. For example, your, if you are not satisfied with your home, your house is having only 2 rooms. Now, if you are not satisfied, means your number of persons are increased in your house, then you are going to extend your house. Maybe the any floor you are using one G plus one or something, you are going to extend, or you have to purchase another another flat or maybe the house, because it is not sufficient for you. So that is what exactly. Only one person is there. Here it is more than enough for one room. If it is increasing, we have to increase it. But once the global depth are fixed, only one family only contains only three persons. Means whatever the house is there, that is free. Only one more person is increasing, then they are going to use another house. So this is the meaning. The same way, same logic here we have used for hashing purpose. Here once the global depth is reached, compulsory you have to extend your particular bucket. Here why extension is required, I told you very clearly, for searching purpose. When you are going to search, here the time complexity must be less. We have to use hashing mechanism. That's why we have to take last digits. It is matching to that particular bucket dictionary or not. If it is matching to the particular bucket dictionary, then we are moving into that bucket and we are going to search whatever the element we are going to find. So this is actual story behind of this extensible hashing. Clear? Sir, even though you please, Rahul Rao, is clear?
Yes, sir.
Yeah, even though please go through my notes. Once you have to check all the hashing mechanisms, practice in your notebook, because once you are listening, it is very easy. When you are putting your pen on paper, maybe you will get some confusion. That's why you have to practice all this second unit. On Thursday, on Saturday, I will take one more class. I'm going to take extra